All right, good morning, everyone, and welcome to How Discovery Increased Operational Efficiency with AWS Observability. My name is Tom Lehman. I'm a Director of Observability and Site Reliability Engineering at Warner Brothers Discovery, and with me today are
Mark Cheney. Good morning, everyone. I lead product and engineering for some of our open source observability services.
Karthik Rangasamy, Solutions Architect at AWS, supporting media and entertainment customers.
All right. So we're very, very excited to talk with you today about observability and some great open source solutions that we were able to use within Discovery to promote a good ecosystem of operational intelligence. But before we get into the process and technology, I wanted to talk a little bit about the company that I work for, Warner Brothers Discovery. Warner Brothers Discovery is the end result of a merger that happened back in April of this year between Discovery Communications and Warner Brothers. The company is responsible for content ranging from HBO's House of the Dragon to HGTV's Fixer Upper, from theatrical releases associated with Harry Potter's Wizarding World to live coverage of the Olympics over in Europe. Warner Brothers Discovery provides, produces, and distributes the broadest range of content and brands across film, television, and streaming. To provide this content, we have a number of platforms, including HBO Max, Discovery Plus, Motor Trend, and more. Behind the scenes, these platforms are powered by technology that runs on mobile devices, smart TVs, tablets, browsers, set-top boxes, and of course, the cloud resources and microservices that underpin them all. Gaining operational intelligence associated with a technical footprint that large and that diverse, serving millions of users on a daily basis, is absolutely essential, but it is also incredibly difficult, which is why WBD invests so heavily in observability. So, what does observability mean? Ask a random engineer, and you may get a blank stare. Or folks may happen to spout out one of a couple of standard definitions. So just that I can better gauge the audience here, I'd like you to raise your hand if you're familiar with one of these definitions that I throw out. First, who is familiar with the control theory of observability? Effectively, the ability to ask a question to your system and understand how it operates behind the scenes based on the data it exposes. All right. If you've been to a talk by Charity Majors or read a book about observability recently, maybe you're familiar with this. All right, no hands. Great, this is the first time that I've seen that. I think I saw one hand back there. Fantastic. All right, next definition set. Who here is familiar with the three pillars of observability? Logs, metrics, traces, yes, there all those hands are. Keep them up, keep them up. All right, folks who still have your hands down, you're either tweeting, which is great, please boost up that social. 2, you have your own definition, and I'd love to talk to you afterwards. Or 3, you don't know how you wound up in this session. Either way, let's talk afterwards. All right. So, as for Warner Brothers Discovery definition of observability, we try to unify a couple of these different topics. We see observability as the unification of all operationally relevant data associated with our ecosystem. This goes beyond logging, metrics, and traces, and goes into things like cost. It goes into things like organizational concepts as well. So for us, an observability platform and solution is really all about being able to provide operational data that is navigable, that is rationalizable, and that our users from a number of different personas can use to make decisions very, very rapidly. Now, this definition and goal is certainly a lofty one. And to be frank, we're never going to reach that goal as a final destination. It's going to evolve over time as we expand and as we grow. But we've certainly made substantial progress over the past year and a half. Back in 2021, we started our observability process from a point of fragmentation, a lack of standardization associated with operational data, and a large bevy of solutions that were playing in the observability space. This also led to opportunities to reduce cost and provide more efficient platforms at scale. Throughout the course of this presentation, you're going to hear about how Warner Bros. Discovery effectively organized their operational data by instituting operational data governance, how we partnered with AWS to define a singular observability platform, and how we expanded on these solutions to be able to provide truly democratized operational data across our ecosystem. Before we get into how we solutioned, I'd like to talk a little bit more about the problems that we were encountering. When I mentioned that we had a lack of data standardization, this related to how we actually organized and cataloged our services and our resources. We didn't have a consistent set of tags, labels, or fields used to understand our ecosystem. Each team was effectively autonomous to be able to define their own fields in their logs, the tags that they would use for their cloud resources, and the labels that would be applied to containerized solutions running inside of a Kubernetes type of environment. While teams running autonomously is certainly a great situation to have, being able to provide that flexibility, it worked well as long as teams operated in isolation. But for an enterprise as large as ours, collaboration was essential. So when one team defined a field that was named app to identify their service and the logs generated from it, while another used a field called service and another said application, it became very difficult to tie these pieces together to understand our entire portfolio of services and data. Further exacerbating this was the heterogeneous set of technologies that were being used. A year and a half ago, we had no fewer than 6 different observability solutions operating in production, serving up metrics and logging data. What this translated into was that if there was a client-facing issue, a developer would need to know no fewer than 4 or 5 query languages, and the same number of user interfaces would need to be navigated to be able to piece together exactly what was happening within the system. Now, does anyone know an engineer that happens to know all of those query languages and happens to have experience with that many tools to be able to effectively manage a situation? Probably not. So more often than not, we'd have to pull in subject matter experts from across a number of teams that had specialties within these different tooling. Because we were so fragmented in technology and tool set, this meant we were not able to invest substantial effort in scaling or making these solutions efficient. This meant that there were opportunities to reduce cost and improve the scaling ability of those platforms as well. All right, let's move into solutioning, now that we know the problem domain a little bit better. Our first and primary target was cleaning up our operational data and driving consistency. Our theory being that if you can at least get that done, even if you have multiple technologies and multiple systems, if you call something a thing and you say it's that thing throughout all of your systems, you can at least start tracing and identifying consistencies across your system. So our first priority was defining an operational dictionary or a vernacular that we would use to describe our entire technical ecosystem. We deemed it the Operational Metadata Specification, or OMD for short. The OMD had the goal of answering a few fairly basic questions about our services and the data that they emitted. First and foremost was, what does the service do? Pretty simple question, right? In order to answer this, we introduced a 3-tiered functional hierarchy to be able to provide some guidance of what our services were associated with. Up on the screen, you can see that we actually have the full decomposition of our back-end logging service that was provided to our broader platform. Up at the highest level, we have a term called a business service, which is a high-level grouping of capabilities. Things like observability happen to fit that bill. Commerce, so all functionalities associated with payments and subscriptions and things along those lines would also be another type of business service. An intermediary layer called OMD service was also provided. This provides an additional grouping and finer grain granularity when thinking about things like observability. Within observability, we have logging, we have metrics, we'll have tracing as well, visualization as a service. Those are all services. Those are then broken down into the OMD component. A component in our mind relates to a specific and unique microservice, common library, or platform that provides a business function. In this case, backend, for backend logging. You'll find later on during the presentation that we actually have a multitude of components associated with the logging OMD service. Additional questions that we were trying to answer associated with operational metadata included, how does a service vary from an operations perspective? We happen to operate a number of products across a wide variety of regions, and some of our services happen to vary in their deployment and configuration based on those locations and markets. So we also introduced a couple of fields associated with that. I don't have that displayed up on the screen, so don't look for them. Finally, we also wanted to incorporate organizational concepts into OMD. Things like who owns a service, what teams actually commit and provide functionality to the code base. How do we get in contact with the team or add a new feature to their backlog? Or in a worst case scenario, what's the easy button for us to generate an incident and get their on call on the line? This was all factored into operational metadata. So we defined our taxonomy, and the taxonomy was set up such that it could be evolutionary. It was schema-driven, and also versioned, so that we could easily update it over time. Next, we had to think about how we would incorporate OMD. We didn't want this to just be a spreadsheet over on the side that someone had to manually update. So we had to think about our goal of providing and relating all of our operationally relevant data. To us, operational relevant data started at the very inception of a service itself. So we came to the decision that OMD should start at the instance of service creation, or in this case, when a repo was created for the actual code to host the service. We essentially created a YAML file that handles a basic configuration storing all of this OMD data and landed it within the repositories of all of our services. From there, our theory was that we would be able to propagate that OMD data throughout the rest of our upstream capabilities and services in the SDLC. CI/CD processes and workflows would all be tagged back to their OMD component and service and business service. This would then propagate that data into our tags and labels, which would then finally push that data associated with each of those cloud resources and microservices into the logs and metrics that they would generate. From this single source of truth, we now had a consistent way of thinking about, rationalizing, and navigating our operational data, and then, through a common visualization tool like Grafana, be able to join a lot of that information in a very tight ecosystem for operations. So we've discussed some of the theory associated with our approach to operational data governance and operational metadata. Let's talk a little bit about making it real. Our first step was first landing those metadata configuration files in all of the 400 plus repositories that we run in. Beyond that, we wanted to be able to extract that data, because while developers certainly operate within their code repositories themselves, we had personas like project managers, leaders, et cetera, that aren't going into individual repositories. We wanted to extract the data out and make it visualizable, make it relatable. So on a daily basis, every 24 hours, we have a scraping job that runs through all of our GitHub repositories, grabs the data from our configurations, places it in an Amazon Aurora Postgres database, and because of the data source connections that you have for Postgres and Grafana, we can then represent that in a tabular form for people to be able to consume and filter and understand our entire service catalog. So we've effectively managed our need for relating and understanding our system through consistent data governance and operational metadata. What we hadn't solved so far was the plethora of technologies that we use in the observability space. So in order to make progress here, what we did was we set a series of tenets for how we were going to adopt the one set of observability tools to rule them all, so to speak. Our first tenet was that we must own our own data. We didn't want to set up specialized, bespoke, proprietary connections to back-end data stores. We wanted easy access to our data to be able to shift it and move it around. We preferred open source over proprietary offerings. Open source has a number of benefits. One, many users and developers happen to be knowledgeable of open source, easier to hire than necessarily proprietary offerings. Additionally, from a backlog perspective and a roadmap perspective, open source platforms and technologies tend to be motivated by the engineering community, not necessarily the needs of any particular vendor. While we did fully believe in the open source mantra, we did still want to defer or move away from some of the operational concerns of hosting some of these capabilities. So being able to hand off some of the operational needs of running open source solutions to a third party was ideal. While we did want to move that operational concern to another group, we did want flexibility in how we deployed our solutions. We wanted to be able to isolate use cases for cost management and also to be able to reduce blast radius associated with different types of use cases from interfering with each other. Finally, regulatory compliance. We're dealing with data, so we always have to do this. So after we had set our tenets, we started evaluating who to best partner with as a part of this. Given AWS's history of hosting open source platforms and solutions for 5+ years and our familiarity with their technologies, we looked to AWS to help us partner on an architectural solution and what they had in store. So I'll hand it over to Mark.
All right, thank you, Tom. I already got one, good.
Good.
So Tom will come back and talk about more implementation details around some of the services that we are using, that he's using from AWS. As a product and engineering lead for some of these services, one of the most important things that I need to do is focus on what matters most for our customers. So some of the things that we are looking at is some of our choices that you have in AWS for implementing your monitoring and observability strategies. So 4 services that Kartik and I will talk about today include Amazon Managed Service for Prometheus, a service to be able to, serverless service to be able to manage and monitor all of your metrics, your operational metrics from your containerized and compute environments, such as infrastructure metrics, CPU, memory, custom metrics. We'll also talk about AWS Distro for OpenTelemetry. So that's a set of portable APIs and libraries and collection agent to be able to discover, collect these metrics, and be able to send them to a destination of choice. And then we'll cover Amazon Managed Grafana, a rich data visualization engine for all of your sources of observability signals, such as metrics, logs, and traces, but can also go much beyond that. We'll talk a little bit about that. And then last, Kartik will come up and talk about OpenSearch Service. So it's a service that makes it a lot easier to ingest and search and analyze all of your logs data. Before we start with talking a little bit more about some of these tools and diving deeper into these tools, one of the things that I want to talk about is some of our reasons why customers choose our AWS managed services. And there are 4 reasons I'm going to cover: security, the ability to trust that our services will scale and be resilient for your production workloads, seamless integration with other AWS services, and open source compatibility. So security is our top priority. We continuously scan and secure, patch all of the components that we have as part of our services. We also integrate with services such as identity access management control to be able to give you access and control over your data. We also comply to general data regulation protection, GDPR, to be able to make sure that your data meets compliancy and is intact for your services and the data that we manage as part of our services. And most importantly, you can trust that the data at rest and the data in transit is always encrypted through the services that you use. We automatically scale and be able to handle the most aggressive workloads that you throw at us for a lot of these services. And we continue to do this as part of our services that we have today at AWS. Some of the things that we do in terms of managing your production workloads is that we take care of the underlying infrastructure. We will scale on demand. And most importantly, let you have to deal with what's most important for you in your organization, which is really dealing with the innovation and make sure that you can operate secure and reliable services for your customers. We also want to make it easier when we want to be able to integrate with some of these other AWS services. So as an example, when you want to keep your traffic secure within the AWS network, when you're integrating with Private Link. And also, when you want to be able to make sure that you can audit who's making changes to these services by using CloudTrail to be able to meet your enterprise governance and compliance. And last, be able to integrate with services like for automation for CloudFormation and Cloud Development Kit so that you can actually manage the provisioning and of these infrastructure as code when you're using these services. We will ensure that you can also trust or manage open source services is compatible with the open source project. Because we want to make sure that when you're using these services, whether they're fully managed or you want to self-manage these services, they will be the same thing in terms of the open source project and the open source standards. We continuously contribute to a lot of these services that we manage as part of being maintainers, triagers, approvers, and contributors from some of these services. Just out of curiosity, by a show of hand, who uses open source technologies? Almost everybody. If somebody's not raising their hand, I'll say the same thing as Tom. You're probably tweeting or doing something else, because everybody should be using them. Most importantly now, by a show of hands, who's actually contributing back to some of these open source technologies? By doing a pull request, merge request, opening up a GitHub issues. So you get to see the difference about how people are consuming this open source technology versus the contributors. And it's the contributors that we rely on to be able to do some of this great work in terms of the open source projects that we have in open source standards. So at Amazon, we love open source. Our team wakes up every day thinking about how we can improve the lives of our builders that are deploying and using open source technologies. Amazon is the 4th largest contributor of OpenTelemetry, which I'll talk a little bit about next. One of the largest projects within Cloud Computing Foundation. Some of the key contributions that we've done for OpenTelemetry include collector tracing and metric stability, including improved Prometheus interoperability. We are the top contributor, and we have 2 maintainers for Cortex. Cortex is a Prometheus-compatible multi-tenanted project, which is, again, is a CNCF project. And most importantly, one of the recent contributions that we've done many contributions as being the #1 contributor, but one that stands out is our ability to do zone-aware Kubernetes controller to make it easier and to safely deploy and update availability zones and to speed up the deployment on Kubernetes. So the great thing is we've proven this at scale for Amazon Managed Service for Prometheus, but this open source project is something that you can use. If you're using Kubernetes today, who uses Kubernetes today? If you're using Kubernetes today, I'd really recommend looking at that project. It really reduced the deployment time by 43% when you're doing OS patching and over 83% when you're deploying these new workloads. So this is an example of a project that is not only applicable to a managed service that we implemented, but we've passed along these operational findings and made that available as an open source project under AWS organization. Some other contributions in 2021, AWS and the open source community created OpenSearch. OpenSearch has, since 2021, has grown to over 100 million downloads since it launched. We also contributed 10+, we've led 10+ of the major releases for OpenSearch and 100+ different features that we introduced in OpenSearch since its launch. Some of these contributions include Lucene 9, observability features across metrics, logs, and traces, and a semantic search. We continue to prioritize new Grafana plugins for AWS. So you see so many examples plugins here. We do changes, we manage triage issues, and we prioritize issues, and we're going to continue to add some new AWS plugins, so including some of the common ones that have been around for a long time, like CloudWatch, Amazon Managed Service for Prometheus, of course, X-Ray, and TimeStream, Athena, and others. So it's important for AWS to continue to be thought leaders and good stewards for the open source community, and we're going to do a lot more. We've done a lot more, and we're going to continue to do a lot more in some of these projects that we're contributing. So let's dive deeper in some of these managed services. So who uses Prometheus? By show of hand, any Prometheus experts? Oh, we got a good audience. Great. So Prometheus is a monitoring and alerting platform that you can use for your high cardinality, high availability, high volume metrics, time series metrics. It's primarily used, it started with Kubernetes types of use cases, used in use cases such as unified container monitoring, troubleshooting and diagnostics, and also workload and application monitoring for infrastructure metrics, as I mentioned, like CPU, memory, disk, across all of your your VMs, your EC2 instances, and your nodes, your container environments. The service provides a serverless compatible monitoring service for Prometheus that you don't have to worry about scaling. Will automatically scale the ingestion, the storage, the query based on your needs as your needs grow with the service for millions of time series metrics. We're fully compatible with the open source data model, including Prometheus query language, PromQL, to help you with the powerful query language to be able to aggregate a lot of these metrics that you have in your environment. The Prometheus service also makes it easier for you to use your existing Prometheus configuration for your rulers, to be able to do alert and configuration rules for your aggregations, and also for your alert manager for grouping, alerting, routing your rules to destinations like SNS, and then be able to trigger things like auto scaling for your nodes, for your pods, for anything else. It's a pay-as-you-go service, so you only pay for the data that you ingest and the storage and the queries that you do for the service. OpenTelemetry was a combination of two open source projects, OpenCensus and OpenTracing, and is really used as a set of APIs, standardization, SDKs, libraries in 11 plus languages to really help you with the discovery, collection of telemetry data, metrics, logs, and traces, and be able to then send the data to a destination of choice. So simply said, you instrument once any telemetry data, and then you can actually send the data to a destination that you want. So you have full control of your data, you can enrich your data, and send it where you want, regardless of the backend that you want to send it. It could be CloudWatch Metrics, it could be Amazon Managed Service for Prometheus, it could be the open source Prometheus, it could be other partner solutions that we have. So AWS Distro for OpenTelemetry is a distribution of the components, primarily the container and the instrumentation agents, used for OpenTelemetry. So this is not a fork of the upstream. We simply create the binaries that we want to be able to make sure that it meets the AWS security standards in terms of components that we include, and meets the performance predictability so that we can offer the support that our customers expect from some of these services and distributions. AWS Distro for OpenTelemetry can be installed in EKS as an EKS add-on, in ECS as a sidecar container, as well as your Lambda functions. So let me walk you through a bit of a diagram to show you how that comes together in end-to-end for a specific use case. We'll take the container monitoring use case. So starting on the left, you have the installation of a collection agent, a Prometheus-compatible agent, in this case, OpenTelemetry. It will discover, collect, enrich that data, and then be able to send the data securely to the managed service for Prometheus inside of a managed service inside of a workspace. A workspace is simply an isolation, a logical and isolated space where all your data and your queries can be done, where you can manage access control to this data. And then using the Prometheus-compatible APIs, you can use managed Grafana or open source Grafana to be able to query the data using PromQL and using all the metadata that's being collected from your workloads. So as Tom was mentioning in terms of the metadata specification, Prometheus gives you that flexibility to enrich all that data, and PromQL will give you the flexibility as part of your alerting rules, as part of your monitoring dashboards, to use that metadata specification like service equal e-commerce, component equal front end, region equal US East 1, and be able to go and collect and be able to visualize all that data. All right, so let me talk about some new features that we've recently announced for some of these services across 3 areas. We'll talk about security and compliance, scale, and single pane of glass. So first, from a security standpoint, we've recently got, about 2 weeks ago, finally got the SOC compliance and ISO certified. That's a big deal for any AWS services that just launches. It takes a while to get through the audit controls. System and organization controls, so SOC, it provides audits of our service controls to help ensure security, availability, confidentiality, and privacy of your data. So it's an important thing that's being monitored and audited by third-party examiners and make sure that we meet those standards. And then also, the other thing that we've recently announced in terms of security is the ability for our Amazon Managed Grafana to be able to connect into your Amazon Virtual Private Cloud, so your Amazon VPC. One of the common asks was that the customers wanted to be able to connect to services like OpenSearch Service, cluster instances, RDS instances, open data sources that you would self-manage, or very sensitive workload that would run within your virtual private cloud, so your Amazon VPC. And ultimately, we needed to be able to make sure that we can maintain that right level of security posture. And now we do support that within Amazon Managed Grafana to be able to do that. So now you can bring a lot of these data together in one solution. Scaling is a continuous journey at Amazon, at AWS. We started with Amazon Managed Service for Prometheus with 21 million active time series metrics per workspace. As I mentioned, you can have as many of these workspaces as you want in the supported regions. We increased that to about 40 million in January, and then we went to 80 million in July. I'm certainly excited to be here today to announce that we now support over 200 million active time series metrics per workspace. And ultimately, we're not done there, right? We're going to continue to grow that. But 200 million, you can now analyze billions of active time series metrics across multiple workspaces in your environment. And very similarly, for Amazon Managed Grafana, for some of the workspaces, we can support up to 10,000 users per workspace. So these are editors and viewers that want to be able to monitor their dashboards and be able to monitor their alerts inside of a workspace. So 3 areas I'm going to cover from a single pane of glass, covering simple onboarding, getting started experience, as well as really trying to make sure that we can bring all these sources of data together. So the first area that I want to cover is more of a solution that helps you bring all these services together, which is a one-step onboarding called EKS Observability Workshop. This is something that I'll share the links at the end so you can actually take a screenshot. And this actually brings together all of our solutions to provide an opinionated configuration for monitoring and availability monitoring for all of your services using Prometheus, Grafana, OpenTelemetry, and using just one command. And then be able to monitor workloads such as Nginx, Java, Memcache, and HA proxy. So it helps you get started if you've never used these services before. It'll show you how to use CloudFormation and Cloud Development Kit and be able to launch these services as infrastructure as code, be able to deploy and manage your dashboards, and start collecting these data from your EKS environments. Second, certainly excited to announce last week we added support for Prometheus alerts. So now you can actually look at the state of your alerts, your rules that are actually evaluating, where your rules are being routed to, all within Amazon Managed Grafana. You can also suppress your alerts. So not only that you can now monitor and visualize everything, you can use Managed Grafana to be able to visualize and be able to see all of your alerts and the state of your alerts. We also added that support through the unified alerting capability in OpenSearch Grafana 3 months ago or so. Last but not least, we talked a little bit about this, is the ability to connect into your private data source. An important thing about a lot of our customers that wanted to bring and visualize all this data together, you can now do this across all the data sources that we support for AWS. We can now support your data sources that have sensitive workloads inside of your virtual private cloud, so your Amazon VPC. And you can also do other data sources from hybrid environments that you're managing. All right, so there's other 5 services that I want to talk to you, 5 features that were very important for Warner Bros. Bros. Discovery's experience, and I wanted to highlight that as part of some of the things that we've done and some of the things that they've either adopted or they will be adopting soon. This includes the ability for us to publish some of the service quota metrics directly in Amazon CloudWatch. So this gives you an ability to be much more proactive in how you can alert when you're approaching service quotas. If you're not familiar with service quotas, a lot of our AWS services publishes these service quotas, and it helps you understand where you are compared to a certain limit that is being available for the service. As an example, active time series metrics for Prometheus, by default, you get 2 million. And now you can scale that up to 200 million. So you can actually alert yourself when you're getting close to that 2 million, so you can easily open up a service request and increase that limit. So we have 10 or so metrics that we now publish. So similarly, what we've also done is created vended logs for Alert Manager. So if you're used to self-managing those logs, there's important issues that you want to be able to troubleshoot and understand as part of importing these compatible logs to the Amazon Managed Service for Prometheus. You can now understand if there's any permissioning issues with SNS, as an example, if you have misconfigured Alert Manager rules, or if there's certain rules that are not firing for a reason or another. So these are some of the things that are now available inside of CloudWatch logs that Warner Bros. Is important as part of adopting alerting capability to be able to understand what's going on with the alerts. Cost attribution. By a show of hand here, who's being asked to be able to better manage their costs and infrastructure wherever you're doing, right? This is something that we're asked for all the time, right? How can you reduce your costs? How can you better manage your costs? About a year ago, we announced Grafana Athena plugin, and as part of that, you could use your cost usage report to manage your EKS clusters and nodes and VMs, all of the typical spend, AWS spend that you have. And one of the things that this does, and mostly in EKS, you gain all the efficiencies by consolidating all your compute resources for your running application. But however, you have this utilization efficiency comes at a bit of a challenge, right, when you get into managing your application costs. So we're certainly happy to announce in September of this year a KubeCost collaboration where you can actually now use KubeCost in your EKS clusters to be able to manage all your application costs. All of these metrics from KubeCost can also be sent to Amazon Managed Service or Prometheus for all of your clusters that you're monitoring. All right, two other things that I want to cover is configurable storage. So that was, again, 150 days worth of storage by default for Amazon Managed Service for Prometheus. Warner Bros. And several other customers, they wanted to be able to increase the actual time, the duration of these storing of these metrics. We now support several years worth of retention. So you simply have to easily open up a service ticket request, and we'll be able to change that retention for a workspace. AWS Control List for Kubernetes, another feature that launched in September, is a tool that allows you to manage other AWS services from within your Kubernetes environments. So very important if you want to be able to use a centralized list of tools to be able to manage not only your AWS or your Kubernetes resources, but also other AWS services. As part of this integration, what we've done is we've added support for Alert Manager and rules where you can actually use a custom resource definition to automatically update alerts and rules directly using this tool that's offered by EKS. All right, so now we've covered 3 out of the 4 open source services. We covered Amazon Managed Service for Prometheus for storing your high cardinality metrics and be able to query those metrics. We've also talked about Amazon Managed Grafana for data visualization for all your operational data and cost usage reports as well. And then we also talked about OpenTelemetry, so the collection agent. So what's next? We got logs, of course, right? So let's bring Kartik to be able to talk to you a little bit more about OpenSearch Service. Thank you.
Thank you, Mark. So as Mark reviewed Amazon Managed Service for Prometheus, Amazon Managed Grafana, and OpenTelemetry, now let's review Amazon OpenSearch Service. Amazon OpenSearch Service is a fully managed service that makes it easy to deploy, operate, and scale OpenSearch and OpenSearch dashboards. Amazon OpenSearch, you could use it for real-time search, application monitoring, observability, log analytics, and much more. Amazon OpenSearch is based on OpenSearch, which is community-driven open source search and analytics suite derived from Apache 2 licensed Elasticsearch 7.10.2 and Kibana 7.10.2. With OpenSearch, you get a search engine, which is OpenSearch, and a visualization user interface, OpenSearch dashboard, and various tools and plugins that support some of these capabilities like observability, real-time search, machine learning, and much more. Amazon OpenSearch Service is highly available and highly secure. All of the underlying infrastructure is managed by the service. So you get capabilities like blue-green deployment for service-specific software updates, various configuration changes such as instant type changes, storage provisioning, and auto-scaling. In terms of security, we support both encryption at rest using KMS integration and encryption at transit using TLS. You can also secure your OpenSearch dashboard using integration with Cognito, your SAML provider, or using the OpenSearch security plugin, which the OpenSearch community offers. There are built-in integrations all the way for ingest, monitoring, security, and visualization. Now let's take a quick look at the architecture of OpenSearch Service. When you use OpenSearch Service, you get what we call a customer domain. And when you provision a domain, behind the scenes, the service is provisioning nodes, which are EC2 instances. You can see here on the center data nodes. Data nodes are the nodes that are responsible for storing data and respond to search and query requests. And then we have ultra-warm nodes. Ultra-warm nodes are type of data nodes that support low-cost storage tier for infrequently accessed data and longer-term data retention. And then we have leader nodes, which are the cluster manager nodes, which perform the overall operation of the cluster and maintain the state of the cluster. So if new nodes get added to the cluster, it keeps track of those, helps with shard management and overall cluster operation, and maintains the health of the cluster itself. On the left-hand side, we have integrations with Cognito, SAML, and IAM for securing the OpenSearch dashboards. And then for monitoring, we have integration with CloudWatch and CloudTrial. And for data ingest, we have integration with Amazon Kinesis Data Firehose, AWS Data Management Service, and much more. So let's quickly review some features that helped accelerate WBD's adoption of OpenSearch. So the first one is ultra-warm. Ultra-warm, as I mentioned, it's a low-cost, long-term retention storage that significantly offers lower cost per gigabyte. Amazon OpenSearch supports Graviton 2 instances. Graviton 2 instances provide 40% better price performance, improves indexing throughput, provides reduction in indexing latency, and improves overall query performance. The third one is a GP3 volume type. GP3 volume type enables customers to provision performance independent of storage capacity. In comparison to GP2 volume type, GP3 provides 9.2% lower cost per gigabyte of data. And fourth, we have cross-cluster search. Customers use cross-cluster search capability for querying and aggregating data across multiple OpenSearch cluster domains. Recently, 2 weeks ago, we announced support for OpenSearch 2.3 that brings in Lucy 9.1 support in OpenSearch, and then improvements in alerts, anomaly detection, and dashboard visualization. I also added a few new algorithms to the machine learning commons library. Now, I'll hand it over back to Tom to walk us through the anatomy of logging and metric service at WBD.
All right. Everybody interested to see how we're putting these technologies to use? Yeah, there we go. All right. OK, so first we're going to talk about logging as a service. So as I mentioned before when we were talking about our tenets for change, the ability to segregate and also deploy different instances of our capabilities based on use case was incredibly important. So for us, this meant that we needed to templatize our solutions as much as possible, which means that we wanted defined technologies for different capabilities within a particular stack. For logging as a service, we broke this down into 3 key areas. First was data collection. In this space, we chose FluentD as our primary data collector. Part of this was due to the fact that many of our engineers were highly familiar with FluentD. There are other options out in the industry that we're currently investigating for a future state evolution, such as FluentBit, and also Data Prepper, which works very, very nicely with OpenSearch itself. Next, we wanted to abstract our data collection from the actual data sinks themselves. For this, we used Kinesis to provide an event streaming pipeline into OpenSearch and S3. This enables us to not only be highly reliable in the case of issues or backups associated with OpenSearch indexing, but it also paves the way for event-driven architectures in the future. Needless to say, OpenSearch is our tool of choice when it comes to operational logging platform. We also store all of our logs in the raw in S3 as well. So, evaluating this solution based on our tenets, we can easily see that operational data can be relatable. FluentD enables us in a Kubernetes-based environment to add labels associated with the pods that are emitting operational data. Here, at the very bottom of the screen, you can see a Lucene query that's pulling all of the OMD service labels out of the fields that are being stored within OpenSearch. We must own our own data, easy access through both OpenSearch and S3. Open source, we know that. This is a managed offering for the majority of our components. Flexible deployments and partitioning. We'll get to examples of exactly how we did this beyond a templatized offer in the next slide, and it's regulatory compliant. So moving on to how we actually use this as a templatized solution. The first solution, particularly associated with the Fluentd use case for data collection, was really geared toward our backend service. So if you think about that OMD classification that I was talking about earlier, we had a OMD component for backend logging. Well, we also had a use case for client-side logging, effectively logs that are being generated from client devices like phones, tablets, etc. This would ingress through a client logger application, and then we set up a templatized pipeline for our logs. So in this case, it would be our OMD component client logs. This worked so well that we then also deployed another pipeline associated with video quality of service or quality of experience data. This is really important within a streaming environment where you want to understand what is the playback quality of your video that is being served back to your customers. And then we started supporting broader infrastructure logging, so CloudWatch logs being ingested into OpenSearch, again, still using the same pattern. And then finally, all of our CI/CD workflows emit events and logs into Amazon EventBridge, which we then also connected into its own unique operational logging pipeline. Moving on to metrics as a service. Similar situation here, taking a templatized approach to how we provide a particular offering. Here, in data collection, we rely on Grafana Agent at this point in time, but we are looking at OpenTelemetry, particularly the AWS Distro for OpenTelemetry, as our next step evolution. For our data store, Amazon Managed Service for Prometheus, and then for visualization, Grafana, and an important element when you're dealing with multi-region, multi-market deployments of Prometheus, you need some way to federate your queries across a number of Kubernetes clusters or AMP as well. And in this case, we are using PromXY. So again, let's take a look at how this measured up against our tenets for decision-making purposes. Again, all operational data must be relatable. Grafana Agent can query out to all of the various pods as well as all of the exporters that we have for Prometheus, like Istio, CAdvisor, KubeState metrics, and Node Exporter, and grab not only the metrics themselves, but all of the labels associated with the pods that are coming from that data too. So every single metric incorporates its OMD data. It's open source. We have a managed offering over self-hosted, flexible deployments as well. We can land AMP, we can land this approach in any of our Kubernetes clusters in any of our environments. And as for using this pattern and expanding, we also provide an option for being able to gather Prometheus-style metrics outside of a Kubernetes and containerized environment. We utilize the yet another cloud exporter, YACE for short, exporter that runs in one of our observability Kubernetes clusters. This reaches out to AWS APIs to grab metrics from CloudWatch and also attach all of the labels from our infrastructure as well. So again, the ability to unify our OMD data with our metrics that are being generated as well. And now we have probably the least attractive slide in the entire presentation, but also a very important one associated with scalability. As I mentioned earlier in the presentation, we were dealing with opportunities associated with how we scaled our system for cost, as well as just being able to support a large enterprise at scale. Roughly a year and a half ago, we actually started at roughly 3 terabytes a day of log data ingested. And at that point in time, many of our query times were closer to around 10, 15, 20 seconds to return data back from our logging data stores. Since our adoption of OpenSearch and our investment within the OpenSearch platform and logging as a service, we've grown our data ingest up to 12 terabytes and reduced our average query time down to 20 milliseconds. Over on the metrics as a service side, we had a much smaller number of metrics that were being generated on a daily basis, closer to about 1 to 2 million or so, landing in self-hosted Prometheus instances. Moving to AMP, we now generate approximately 7.3 million metrics per day within a production environment, with plans to grow up to about 50 to 60 million, not too distant future. We currently trigger approximately 100,000 alerts per day through Prometheus and AMP, and run about 700,000 different queries related to alerts as well as our standard out-of-the-box dashboards. One thing that we haven't mentioned is how we gather some additional data. Like I mentioned, observability to us wasn't just about logging, metrics, or our service catalog. What was also important for us was a self-sufficient and highly automated catalog of what cloud resources we have, so that we could easily understand what resources were associated with which services, regardless of whether they were generating metrics or logs at any given point in time. So for this, we built out our in-house platform for grabbing and understanding this infrastructure. On a daily basis, we are running jobs that are executed through Cloud Custodian and Kyverno running in Kubernetes to scrape all of our Kubernetes resources as well as cloud resources, extract that data, and land it in S3 so that we have a generally up-to-date, at least within 24 hours, catalog of every single cloud resource in use across WBD. This results in about 150,000 resources scanned day to day across dozens of accounts. Now, our goal was unification of all of this observability data. Now, with the OpenSearch solution and logging as a service, we had effectively landed 5 to 6 different logging as a service capabilities. That eliminated 5 to 6 different tools that were being used for logging for each of those use cases. Now, with that being said, OpenSearch by itself is its own tool. It's separate from Grafana, it's separate from Prometheus. What we wanted to provide was an ecosystem that developers could go to for any operational concern. This is where we started building out what we called the observability station within Grafana. This is a set of out-of-the-box dashboards that we built that interconnected different operational concerns for all of our services that were operational, and it was tied together using OMD. Because Grafana gives us the ability to query back to all of the AWS data sources that we happen to have, we could provide an interconnected experience across these screens and make this data much more relatable to our engineers. So we're going to walk through a couple of these screens and the data that gets represented in each. First is the infrastructure catalog, which we just covered. All of this data is being sourced from S3, and that is then being queried using Athena and then visualized within Grafana using its Athena data source plugin. Here you can see we're able to filter and sort based on business service, microservice, or component, identify which accounts different resources happen to be operating in, with high-level visualizations associated with this data, and robust detail provided in the table at the bottom for every single cloud resource that we are scanning on that day-to-day basis. Teams can easily navigate and carry with them the filters that they apply to the infrastructure catalog to our standardized operational dashboards. Our operational dashboards pull data from a combination of Amazon Managed Service for Prometheus as well as OpenSearch to expose over 150 metrics and log visualizations for our teams. So teams can go here for a summary view, which you're seeing here, navigate to a detailed view associated with networking traffic associated with their service, or a saturation view to understand CPU, memory, disk utilization of their pods, containers, and infrastructure, all without them having to lift a finger. Now, one caveat here, we do provide teams the autonomy to build their own dashboards. Everyone wants to write and build their own dashboard. It's just the way that we operate. We want our own way of visualizing our system. But what these provide are folks that aren't familiar with a service are given an out-of-the-box mechanism by which they can understand the health and operations of anything within our ecosystem. Next, we provide visibility into CI/CD as well. So if you are looking at your operational detail dashboard associated with your P95 latency and are interested in why it's spiking up, you can easily come back and see what has happened associated with our CI/CD processes as it pertains to your component. You can see when the last workflow executed, whether it was successful, whether it failed. If it did fail, was it failing because of a test not passing or some type of functionality as a part of the deployment process not going all the way through? Additionally, this is useful for things like higher level reporting for project managers and leadership because we can see trends associated with all of these processes over time. And finally, tying it all together is our service catalog. Here, we're looking at an entry for an individual service where we are unifying data from our cloud resource catalog, the organizational data up at the very top. You'll see that I own this particular service. It also provides information associated with the Jira project, the incident management tool that we can connect, the code repositories that are associated with this service. We are pulling live data from Istio and storing within AMP to be able to understand the upstream and downstream dependencies of the service. And we're also pulling in that CI/CD deployment data at the bottom as well. So this provides a fully unified view of a single service to give you all the information that you need at your fingertips. So we've gotten to a point where we've started unification. We have our consistency associated with our operational metadata. What's next? Well, there are a few different capabilities and opportunities for us still to solve. One is the ability to convert logs to metrics. One of our philosophies is to have a singular capability for alerting across our organization. I'm sure many of you have been in a situation where you've derived alerts from logs. Are those efficient? Have you ever run into issues associated with your logging platform because someone ended up writing a very expensive logging query? Yeah, I'm seeing a few heads nod across the board. All right, so one thing that we want to move to is near real-time conversion of logs into metrics that are then moved into Prometheus. This gives us the ability to be able to have a consistent mechanism for being able to generate alerts and catalog those alerts across our organization. Like Mark mentioned earlier, we also want to start doing Kubernetes-based cost attribution. Cost Explorer works great when you have standardized tags for your cloud resources. The problem becomes when you're looking at multi-tenant systems like Kubernetes. You can't extract information about the pods or the services operating within that environment. The same thing goes for Kafka or OpenSearch. How do you actually derive the cost being driven by a given service? We're also looking at OpenTelemetry-backed distributed tracing across our system for raw event tracing from source to source. And then finally, like Karthik mentioned, OpenSearch cross-cluster search optimizations. So as we're bringing this presentation to a close, I'd like to leave you with a few key takeaways across the board. First and foremost, if you're starting a new project or need to revamp an old one, please, please, please govern your operational data. When it comes to the operations of your systems, incident management and debugging, taking a serious approach to operational data management is just about as important as business data governance as well. Next, minimize the interfaces and query languages in operations. Reduce the number of hops that an engineer needs to make in order to understand a system. Then, leverage managed services where you can. Unless you happen to be in the business of providing observability capabilities, you're probably not going to be making your company an extra buck by self-hosting an open source solution. So look for options where you can offload some of those capabilities. And then finally, try to provide options that minimize reinventing the wheel. Right? Many teams, many services need to know their latency distribution. Many need their status code breakdown. Not everybody needs to learn how to do that for every single service and reinvent the wheel across the board. So try to provide options that reduce that type of reinvention. Now with that, I'm going to flash some information and QR codes. Feel free to take a picture of this for additional resources. But we're going to move to the thank you slide. We have a survey as well, and I'd like to invite Karthik and Mark up to the stage. We have a minute in the case of probably one question, but we're certainly going to be sticking around after the presentation if you have any questions up at the stage.